Okay. All right, so let's look at this, because this is a good question that you could be asked, you know, either in multiple choice, like maybe they would give you, and a lot of times, you guys, just so you know, on the AP test, they love to give you a picture and then say, like, use this for questions 35 through 38, you know, like where you're referencing the same diagram. All right, so if you look at this, okay, what did you write for your balanced equation?
CL plus 3.
Okay, how many were unsure? Don't raise your hand if you're on camera. How many were unsure how to write the balanced equation? Let's be honest. Okay, let's look at what we have. Okay, first of all, who are our reactants? Chlorine and fluorine. However, what do we know about chlorine and fluorine? They're diatomic. Now, admittedly, what if you didn't remember that? You didn't have to. Why didn't you have to remember they were diatomic? In the picture, they're showing you there's 2 chlorines, there are 2 fluorines. Do you see the, like, you have to consult the pictures, okay? So you should have Cl2 plus F2 yields, and then your product was chlorine trifluoride. What is the formula for that? ClF3. Okay, are we balanced? No. Put a 2 where?
In front of Cl.
Which Cl?
The product.
The product side Cl. So put a 2 there. That's correct. What else do we need to do? Put a 3 there. Okay. Does anyone want to take a minute and relook at their other answers before we go further?
Yes.
Okay. Take a minute. Reconsider your other answers before we move forward, okay? Because it's going to be dependent on that first answer, isn't it? So take a second. While you do that, I'm going to draw myself that circle thing. Oh, wait, no, I don't have to do a fancy one. This is my favorite trick I learned last week. Why isn't it working? Why didn't it work? I have to, like, perfectly stop. Of course, when I actually want to do it and I'm not just doing it for fun, it's not working. What? Is it because I'm going past my spot, Elizabeth?
You might have to just hold it in the same spot. Yeah, you have to hold it down. No, you have to go to the end of the circle and hold it down.
I am going to the end of the circle and holding it down.
No, like in one motion.
I did.
Yeah, no, hold it in.
No, you know what the problem is? This isn't my iPad. So it's not updated. No, I know. I can do it on my iPad. This isn't my iPad, which means this software isn't updated. That's the problem. That's it. So, all right. Well, so much for pretty circle. I was like really excited about that. All right. So, who is the limiting reactant here?
Chlorine.
Chlorine?
Chlorine.
Fluorine? I heard both. How many say chlorine? How many say fluorine? How many say I have no idea? At least you're honest. That's fine. Okay. So here's what you need to do. What's the advice I give you every time I say you see one of these diagrams? Count them. Who's chlorine? Green. How many of those do I have?
6.
No.
3.
I have 3. I have 3 Cl2s. Okay? I have 3 Cl2s. So I'm going to put a 3 up here just so I remember. How many F2s do I have?
6.
6. There you go. I have 6. Okay. So what is my ratio of what I actually have? It's 1 to 2. What ratio do I need? 1 to 3. Correct? This is what I have in red. This is the equation, my theoretical. Right? It's supposed to be a 1 to 3. What I actually have is a 1 to 2. Which means if I have 3 of these, how many of these would I need to keep this? I would need 9. Do I have 9? No. Therefore, who is limiting? Fluorine. Okay. What does your circle look like? What did you make? How many fluorines do I have? 6. No. Well, I have 6, so total, how many fluorine atoms? 12. How many go in each of these? 3. So total, if this is my limiting reactant, how many can I possibly make here?
4.
I can only make 4 of those because of, right? So I'm going to make a like this, right? And then we'll do green. Right? I'm going to make 4 of those, correct? So I'm going to do that. I could really just make my life easier by making my dot a little bigger here. There. 1, 2, 3. Okay, and then we'll use yellow. Bump, 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 bump. Is that it? No.
You gotta draw your 2 other chlorines.
Because I need to draw my leftover chlorines. How many leftover chlorines do I have?
2.
2. So, 1, 2, 1, 2.
Sugar.
Right? Autumn.
Wouldn't they only be 1 extra?
No, because good question. Wait.
Yeah, because 2 is only 1.
Yeah.
Yes. Sorry, I got excited. You're right. Yes. Yes. Good correction. Yeah, because we use 2 of these, right? We use 2 for 2 to 6, which is 1 to 3, which means we have 1 left over. So yeah, good. Okay, now I'm going to add to this one more question. You're going to love it. If the reaction only produced 3 CLF, sorry, 3. Yeah, that's my workaround there, because I just reduced my font. Molecules. What is the percent yield? What's the answer?
75%.
75%. How'd you get that, Jonah?
I divided 3 by 4.
Right, 3 by 4. Why?
Because we made for CLF3, and that's what the equation, that's what we should get. And but we only got 3 according to that question.
Okay, yep. This is your actual. This is your theoretical, okay? Like your theoretical, you guys, is your on paper mathematical answer. If every little bit of reactant got converted to product exactly the way it's supposed to and everything went smoothly, here's what I should make, okay? It's your on paper answer. What happens in the lab is your actual results compared to your on paper answer, okay? So if the reaction only produced 3, well, we know it was supposed to produce 4, right? So actual divided by theoretical times 100, right? I didn't do that part yet. Times 100 is 75%. Elizabeth? Funny you should ask. I was about to give you one last practice one to do that way. So, okay? Are you ready? Okay.